the different kind of interface group you can have, right? Different kind of mode, right? LSCP, static, right? Multi-mode, static, you know that, right?
I don't know, sir.
Yeah, so I'll show you that one. So basically what happens is multi-mode means, suppose you are creating interface group like E0, uh, E0L or something like that, okay? Just giving an example. E0L or something like that, okay? So what you can do is, uh, if you're mentioning the interface group as multi-mode, right? LSCP multi-mode, then what will happen? Both the ports will be active, okay? And if you're mentioning as static, then what will happen? One port is active, another port is passive. And if there is some issue with any of the ports in the multi-mode LSCP, right? Then what will happen? The interface group will be partial. It will not be full, and you will get errors. If you want to fix it, you have to check whether the SFP is the problem or some other hardware problem in the port, or maybe you can use some other port for that. Okay. And you know about failover groups, right? Failover failover groups. Failover groups. So normally what will happen, uh, if suppose a port of particular broadcast domain is having a problem and leaf is on that port, then leaf will fail over to some other port, okay? And that will happen in broadcast domain wide. It will happen broadcast, one second, broadcast domain wide, okay? And you know what is IP space, right? IP space is basically, if you have different tenants, suppose you are working, you're you're having one array or maybe multiple arrays, but you have two different customers, and one customer cannot see the data of other customer, okay? So you can use IP space in that case. Normally you will have two IP space: default, cluster, and default IP space, okay? Cluster IP space is for management ports, management leaves, everything management related to management, okay? Like node management, cluster management, admin SVMs. And default IP space is for data purpose: CIFS interface shares, LANs, iSCSI, I mean FC, iSCSI, S3, everything else, okay? And IP space and the broadcast domain, right? What is broadcast domain? Broadcast domain is broadcast domain is for, it's basically scoped like to combine ports, okay? So you'll also have two broadcast domain: cluster and default, okay? So the cluster broadcast domain is tied to the cluster IP space, and default is tied to the default IP space, okay? So and it will have the cluster ports here, management ports here, okay? And it will have the data ports here, okay? You know SVM, right? How many SVMs are there, right? Admin SVM, data SVM, right? So admin SVM is just like cluster SVM and all those things, okay? And data SVM is for data purpose. Data SVM is for data purpose, okay? One second, just one second. So I'll just explain the basics now. Okay? One second. So yeah, so data SVM, admin SVM, okay? Let me see whether the PuTTY I am able to access the PuTTY or not. If I am able to access, I'll show you here. One second. Because what I am showing you the basics, that's very important. The basics is good, right? I don't know. I think let's check, because not every lab is having the access. Yeah, it's having. Okay. First command in data, we have to give it row 0. Why row 0? Because if I do not give row 0, I execute a command, I cannot see the full output. You understand, right? I have to give enter again. It's just a output like more, pipe more. You understand, right? Linux pipe more means it will not show the full page. Okay. And what is network interface leaf? Network interface leaf is like a is like entity where you tie the IP with on a port. You understand, right? Leaf. This initially this first these leaves are for what? Intercluster switches. They are using private management. I mean private IP, public IP. This is private IP. Okay. This is not for our in use. This is only system Netapp on-top system will use for the internal communications, cluster communications, and other things. Okay. So suppose you have a two-node cluster. Here I have how many nodes? Yeah, two-node cluster. Okay. Then HA is also configured. Yeah. What does it mean by HA configured? HA configured means these are part of one cluster. Okay. These two nodes, and it means that if one node is down or some problem is there in one of the disk shell in one node, right, the other node will come to know. How they are coming to know? Because they are sending the heartbeat informations from one node to another node using the cluster interconnect. Okay. So what they will do, if suppose node cluster 1 is down, right? Cluster 1, suppose it's node 1. Okay, node 1 is down. Okay, then you know that the it's like here Netapp cluster 1, here cluster 2, here the disk shelves directly connected, here the disk shelf directly connected, and it's also connected like this. Okay, so if this is down, it can access this one. It can even though the disks are owned by this node, and the leaves will migrate here. Okay, so it's very it's very powerful thing, but it was not there in 7 mode. It's 7 mode. 7 mode also clustered these things were there, but it was manual intervention was required. It was not easy as like this. Okay, see the first, this is cluster management port. Okay, sorry, this is cluster management port. Okay, and these are node management ports. Okay, and what is this port? Intercluster port. So intercluster leaf. Why is intercluster leaf? This is for replication purpose. We need to create. Whenever we want to do replications, we need to create intercluster leaves. Then we need to do cluster pairing, SVM pairing, lot of other stuff. Okay, so you have to understand that. And what is this? SVM cluster 188. This is a 1 second. These are going to show. Okay, so this is for data management purpose. This is for data management purpose. I only have root. I only have. Let me check if I have some other volume. It's a root volume. Yeah, it's okay. Yeah. See, the first volume that you see right here, this volume. Whenever you are creating a V server or SVM, this root volume will be created along on that. Okay. Whenever you are creating any other data volume, the data volume is being mounted on this root volume, junctioned into this root volume. If the suppose the data volume name is what, D1, right? So junction per normal will be /D1. Let me show you this. D1, and then here there is no junction path. They have not mentioned any junction path. Maybe for some other LAN they have mentioned junction path. No. Okay. They have not created. These are all lab created. Okay, these are not created by me. Okay. So basically, whenever you are creating any V servers, right? V server show. Okay, see, this is admin view server, this is node view server. So whenever node is being created, right, during the time of installation, initially you will create the first node, and then you will access the node IP either through CLI or GUI, and then you'll configure the cluster. You'll give the IP of other node, cluster IP, and all those things you need to do. Okay. So whenever that cluster is being configured, I mean the database is being installed, right? This node vservers will be created, and every node will have one root aggregates. Okay, root aggregates. And root aggregates, the naming convention, the name will start from AGGR 0. AGGR 0. Okay. So, and this root aggregates will be mainly rate DP. I have also discussed advanced type partitioning. I'll show you later on. Advanced type partitioning. Okay. So, rate DP means what? So, it will be rate DP. Rate DP is what? DP means dual parity. It means in a RAID group you have two parity disks. That means you can have, it is protecting you from two disk failures in a particular RAID group. Means even if you have two disk failure, your data is safe. Okay. In Netapp, I can have RAID DP, I can have RAID TEC, I can have RAID 4. In software defined storage Netapp, we can have RAID 0. Now one more thing, what is software defined storage? Software defined storage means it's just a software. It does not have any hardwares. The backend hardware can be Netapp, it can be Hitachi, it can be EMC. In my project it is Hitachi. Okay. So here in software defined storage the RAID will be RAID 0 only. Why RAID 0? Because it's already protected by underlying Hitachi storage. I don't need any more RAIDs. Okay, because if I configure any more RAIDs apart from striping, you are not having any protection in striping, so you are not losing any space to parity. Like your user space is increased, user space is more compared to RAID DB or any other RAIDs. Okay. So what is happening? I'm using RAID DB, right? So one data disk, two parity disks. That is the normal configurations. That by default ONTAP will take. And why do you need this aggregate, root aggregate? To keep the node ONTAP operating system, to keep the audit volumes, to keep the Snapmirror mapping volumes. Mapping volumes means it's just will have the map data, like how it is mapped, like that, like metadata. It's not the actual data. Okay. So, and these, yeah. Hmm. Three disk. Three disk. Yeah. Hmm. Hmm. You have to configure in such a way that it does the same rate group, like 1D plus 2P, right? So you add disk again 1D plus 2P. Yes. 3 disks. Yeah. Yeah. But normally you will not be expanding root aggregates for sure. You'll not be expanding root aggregate. Mm-hmm. Yes. No. Here the data aggregate is different. Here it is not 3 disks. Let me show you how many disks there. Mm. Data aggregate by default you can choose as per your convenience. It's not like this is during the time of installation. We do not have any options to mention how many disks. Okay, because it will take as per the Netapp operating system, on the operating system. Do not have any options. So I will just check aggregate. Yeah. Mm, 1 second. So how many disks is there? 13 disks is there, right? And what is this rate? Read DP only, right? So that means what? 13 disk read DP means what? 11 plus 2. 11D plus 2P is used here. Okay. And you can also create mirror aggregates. Here it will show us, instead of normal and comma mirror, it will show. Okay, normally we do it for root aggregates. Okay, and I have done it for my software defined storage array. I have mirrored it. Here they have not. It's a lab, right? It's a sim. If we if we just check the version here, it's a sims. Yeah, yeah, root aggregate mirroring. Yeah, yeah, mirror aggregates. So, so that means what mirror? Yeah, because the read will be faster, mirror, and you will also not have data loss because it's software defined storage, right? It will have its own limitations. Software defined storage is just a storage, just a software. What you have to do is you will be going to the Netapp support site. You'll be downloading the software, like not a software, just OVA file, like OnTap deploy. You'll give that OVA file to your Wintel team. They will create a VM out of it. They will give the IP to you. You'll access the IP in web browser, and from there you'll configure the Netapp nodes. And while creating the Netapp cluster, OnTap cluster, when you are creating the nodes, it will log into the underlying ESX server. So you'll be giving the vCenter admin permissions there, uh, added in that OnTap deploy. It will log into the byte. I mean the applications. Uh, it will. I mean the REST API. It will log into that. You will not log in. It will log in itself. It will create the VM. The VMs are basically nodes. Okay, and you need to allocate storage from Hitachi to ESX server, and you need to create a data store in ESX server, and you need to assign the data store to OnTap select. Okay, and then you can you will be able to see the storage, and then you have to configure all the things, aggregates and everything. And during the time of installation, you can mention like mirror aggregates or something. You can mention there. So because it's and even though it's mirror aggregates, it will be RAID 0 only. It will not be RAID DP. Okay. Do you know SnapLock? SnapLock means if you aggregate or a volume using SnapLock, it means that it is using WRM. Write once, read many times. That means what? You are writing a data to it, but you cannot really edit anything. You can only edit one time. Then you'll put some snapshot policy retention period. Okay. Only after the retention period is expired, you'll be allowed to write again. It's just to put image files or files that you don't want to be you don't want someone else to modify those files. In one project, yeah, it's a SnapLock constant. Yeah, data volume. Yeah, yeah, of course. Yeah, this is data volume only. I'm showing, but not root volume. There is no need for root volume to do SnapLock. We are not going to access anything from root volume. We should not do. We should not do actually. Why do yeah, we don't do. There is one more thing. Suppose the SnapLock is a feature which was like it was you had to purchase a different license before 9.7, but nowadays it comes bundled with the OnTap. You don't need to buy any license for this. You see that NVMe, this is NV capable, so no, false. So here what is, so you see all these things here, use size, this string I'll use for in my Ansible lab. Okay, so these are all the things are there. Mm, you see, right, all these things are there. So I've explained aggregate. What else I have? Subnet, subnet, right? Subnet is basically a pool of IP. So you need to create a subnet, mention the domain, the subnet range, uh, the net mask, and whenever you are creating a leaf, you just mention the subnet name. Okay, you need no need to give any IP. So it will automatically choose the IP from that particular range. So creation of IP, huh? What? What are you saying? Yeah, the range you will get from the networking, but you have to create here. You have to create here. So this is used to simplify the management of lift. Otherwise, you have to give lot of options, right? So that's the reason. To simplify the management lift, we create subnet. Do you know DNS? I mean, in Netapp. So you need to create DNS. Okay, you need to mention you'll have the DNS servers from your Wintel team. You have to mention this. Uh, you have to create this here. Okay, normally you'll have two DNS servers. You need to have DNS load balancing. That's the reason. But we have limitations here. We only have one DNS server. Do you know NTP? I don't know why NTP command is not working. Okay. Okay, NTP is not complete. NTP is basically is a time for time synchronization. Your your time zone should always be same with your NTP server and your Active Directory, DNS server, some DNS server. Okay. The reason why, if it is not same with the Active Directory or DNS and DNS server, the problem will happen is that you'll have LDAP authentication problem, you'll have DNS resolution problem, lot of problems will be there, and these problems will be seen, will be prevalent mostly in CIFS or CIFS shares. Okay, so that's what you have to know. And what else? You know this one also, right? What is CIFS server? You know, right? Export policy. Okay. Okay. I think we have given enough time. Hmm? Yeah, multi-protocol. You can enable multi-protocol. So if you are enabling multi-protocol, right? So what you have to do is that your vServer will have SMB and NFS enabled, and when you are creating the volume, it should be a mixed. The security style will be mixed. Instead of having only NTFS and NFS, it will be mixed security style. Security style, okay? Hmm. You know export policy rules, right? Then you don't need basics. You need lot of you know a lot of things. You know a lot of things. Okay, export policy rules. Okay, so what else I can teach you? Advanced type partitioning. I'll teach you that one. Okay, you probably don't know that, right? Yeah. Just one command there. Let me check if I am able to run or not. Not run. IFCFG. IFCFG. I think command is wrong. Not IFCFG. What is the command? IFCFG. It's start, right? Sister, no. It start. Start hyphen Z, I think, or maybe. Yeah. So we are just going to the basics, bro. Okay. So just moment. Hyphen A. Yeah. This is to check CIC errors. Okay. So if you have any CIC errors, uh, in transmit receive, right? Transmit and receive. If you have any CS errors in receiving side, right, that means you have to change the SCP port on Netapp side. If you have the CRC errors, where is the CRC thing? Total here there will be some CRC discards. I know I have to check. This one, yeah, CRC errors. Okay, it is 0 here, but I'm just saying if you have CRC error here, then it's like a Netapp SAP you need to change. If you have a CRC error here, transmit here, okay, then you have to uh, change the switch side SFP, okay, and anybody can your data center guy can change the switch side SFP, but you have to bring your Netapp to change this SFP on the Netapp side. And one more thing, if you have any CRC error on a quad SFP port, then quad SFP even 4 port will make a quad port, okay, quad SFP. So if you are replacing a quad SFP and then one port is having issues, then you have to migrate the leaf from the other ports to some other port which is part of the same broadcast domain, and you have to put the auto revert as false, and then you have to replace the QSFP. It will be done by Netapp, and then you have to again change the again migrate it, revert it back, and again then change the auto revert as true, okay. So and then and how do you find those things? There is a command, what this one, okay, same time. Please mute yourself. Mute device. Yeah. So this is the command to see where which switch your which Ethernet switch is being used for your data communication, like CFS and FS. Okay, so you will be able to identify, is this a simulator, right? So it's Simbox. So if I'm having some issues with some ports, right, I will check, okay, this is a switch, and I see like I see like transmit some problem is there, right? Transmit side CRC error, as I showed you the last command, right? What is the last command? Instead of this, I'll just give like E0 A, okay. What actually hyphen Z or what is? No, not hyphen Z. E0 A, yeah. So this side here discards are there, right? Then you have to check the SFP side, and you can find the which port is there from that network device discovery output. And if this side is there CSA, that means you have problem with the Netapp side. You have to replace the SFP in the Netapp side, okay. Then I'll quickly go in this lab, bro, because this lab I have to do, yeah. So 1 second, I was explaining to you basics, okay. So the thing about Netapp is you can do a lot of things in Netapp, but you really cannot do a lot of things in Hitachi, unfortunately. It does not matter how much you know, you will not be allowed to do, okay, because Hitachi vendor will not allow, okay. So today we'll discuss some other concept. Today we'll discuss this as Snapmirror active sync. It may have have anyone got the chance to work on this one, this Snapmirror active sync? far? Have you worked on Snapmirror ActiveSync? I think no, right? What about? Okay, so this is basically, I mean, back in 2014, we used to call it as Snapmirror Business Continuity. Okay, nowadays they call it as Snapmirror ActiveSync. Okay, so this is basically a synchronous replication, technology that Netapp is using. Here also the RPO and RTO is good, like RPO and RTO is 0. Okay, so it will synchronously replicate multiple volumes. Okay, between like distant locations, like geographically distant locations, and still it will achieve like 0 recovery point, man, because it's synchronous, right? It will, but still it will have some round trip delay, because it will wait for the acknowledgement of data written on the secondary side. Then only primary write will show, the acknowledge, okay, that yeah, write is completed. So it will have round trip delay, but it's synchronous, and it is supported on all flash arrays, AFF arrays. Okay, and it will also support it on all SAN arrays. Okay, all SAN arrays means the arrays that will be repackaged as SAN arrays, packaged as SAN arrays. Okay, so but there is a problem. Suppose you are doing Snapmirror, right? You can have doing Snapmirror between AFF and FAS. Okay, but if you are doing like Snapmirror ActiveSync, right, then it has to be like AFF or ASA. Okay, it cannot be FAS. I cannot use FAS. In my environment, I showed you guys, right? FAS we can do. I don't know where using. I think FAS only. So not I have shown you. I've just told you, right? We can do. So FAS, right? So the thing is, but active async is not FAS. It's all flash array and ASA, like all SAN array. Okay, so you can use those things. Okay, so this is used for mission critical, business critical applications. Okay, and the license you get for this kind of applications in TB wise, like this TB, this much TB, like that. Okay, you'll get the license like that. Okay, so here in ActiveSync, right, you can do like use, I mean, you can replicate the lungs, I mean the volume only, but it's used for SAN replication also, so which is a very good thing. Okay, in Netapp basically whatever you do, Snapmirror, everything, right, it can replicate both SAN and NAS, because you are replicating only volumes. Okay, it's just saying that it's specifically for lungs, like all SAN arrays. Okay, that's what I'm saying. And it's a technology which is like very easy to create. It's not like the metro cluster I show you guys. Metro cluster was fairly complicated. GAD is very complicated, bro. I don't know how to show you GAD, because I do not have lab for that. I probably have to show you some different way. But GAD is very complicated. Okay, but compared to that, it's very easy. So here, this ActiveSync, it can protect any application with that is having using iSCSI or FCP LUNs. Okay, normally I think you are using SAN, right, Swati? Netapp SAN, right? No SAN, right? Yeah. Normally Netapp, nobody will use Netapp SAN normally. You will have some other vendor like Hitachi, EMC, even Pure also. Okay, I think Nando is working on Pure. HP3 power, yeah. HP3 power is, I don't know how good it is. My friends are working in HP3 power, HP3 power or HPV, but I feel like they have been repackaging the this Hitachi array only in their HP brand name, and they are selling it. They have been doing this for a long time. So it's, I don't know, but so anyway, so that's what I came to know from Hitachi trainers back in 2011 or 2012 when I went to Hitachi Vendor Bangalore. I used to stay there. I stayed there for 3 months, I think. TCS sent me there. Me and two managers went, and then we used to take the training and all from one guy who came from Singapore, Rahman. So anyway, it's a long time ago. My first storage was Hitachi only, but the problem is, it's very difficult to do a lot of things in Hitachi because Hitachi will not allow you to do a lot of things. You can only do things like replications, migrations, like little bit of troubleshooting, because most of the things Hitachi will do, right? Uh, they'll have some tools. Okay, I'll not go off the topic because it will take a lot of time for me to do this. Okay, quickly, one second, using time. So, admin, Netapp, Simbox. This is simulator. That's will show Simbox. When you install simulator in your own environment, it will also show Simbox. Okay. Then I have to set up the replication. Right. The first thing that I will see is whether my intercluster leaves are there or not. Come to this. Leaf is basically an entity where you tie the IP on a port. You are accessing, suppose you are accessing a CFS share, right? What you will do, you will put the IP of a leaf, of a leaf that is used for the particular vServer, okay? And then you will dig down to the volume that you want, right? CFS shares on that particular volume. So in Netapp everything is a leaf. Even if you are using SAN also, it's a leaf. But in SAN you are having two leaves per node. The reason being you need the LO and MPIO. You need the multipathing, okay, and also you need the round robin process. The way it will do multipathing. It's basically logical interface, you can call it leaf. Like I don't know whether you attended the training or not. The one where I explained the network basics. So there I have explained this, okay, this leaf, okay. So what you have to do is when leaf is created initially, right, these leaves are created. This is for inter-management purpose. These are all private IPs. You cannot access them from outside. This is for Netapp's internal networks. And these are public IPs. You can access from outside. Initially, when you do Netapp installation, you first need to give the node IP, right? So suppose this IP. Then you give cluster IP, right? So these are for management. This is node 1, node 2. This is cluster. And when you create applications, you need to create intercluster leaf. Here it's already created, okay? In one of my labs, if you go to the video, right, I'll show you again. In SVM DR applications, I showed how to create intercluster leaf, okay? Intercluster leaf. If you have two Netapp, right, two different Netapp, geographically distance locations, some maybe Mumbai, Chennai, something like that. Okay, so what you need to do is that you need to ensure this leaf can ping, not this leaf, sorry, this leaf can ping to the other array that is in, it is proposed this in Mumbai, Chennai, okay, other array which is in Chennai, it can ping, it can reach there, okay, it can ping. If it is not pingable, then you cannot create cluster peering or any kind of replications. You have to ensure that you have to use proper port. You should not use a management port like E0, E0B. It will not work if you do that. You have to use the port which is part of data IP space or data broadcast domain. Okay, I showed you, not data, sorry, default. I showed you, right? There are two broadcast domains, cluster and default, right? So this is the way. In Netapp, if you know the basics, you can do anything. But to understand the basics, it's a big challenge in Netapp. It's a very big challenge because the Netapp basic is very big. That is a problem. It is dependent on networking. You see the speed is here, right? I have never restricted any speed in Netapp. I have changed the MTU size, yes. MTU size I have changed, but I have never changed the speed of Netapp. I don't think we can change, okay? But I have to check. I don't think we can change because because the reason why I had to change this is because the Ethernet switch that I had, it was not able to support 9000. It was able to support only 1500 for this cluster management ports, okay? So that's why they were, I mean, the network team did not have that equipment to support for 9000 MTU. You understand, right? I'm talking for software defined storage array, not for this array, software defined. Because this 9000 MTU will always be there because we are using a intercluster switch that will buy from Netapp only. You'll buy that from Netapp only. You will not change this, but you will change this in software defined array, software defined storage, because you will not have 9000 this MTU. You can have, it's not like you will not have, but we do not have in our project. We do not have, so I had to change it to a lower MTU size, and for that it gave me a warning, but we cannot do anything, right? I mean, nobody wants to put money on that. So but speed will not change. I never change speed, okay, of ports. It's not like in Hitachi we can change. We do, but we don't change. Even I asked the vendor, right, that there are some credit stall device. The HBs are very old. They are supporting only 8 GPS, and Netapp is Hitachi is supporting 30 GPS. Can I lower down? Can I, can I not for port actually? Sorry, not for device. It was for long distance ISL ports. I asked them, okay, can I change the replication port as 16 GPS? They did not reply. They said you need to pay money and buy a package, professional membership. They will design your environment. That's what they said. They didn't give me the answer. Okay, so that's the thing. And while I was part of TCS, right, if we ask an informational thing, right, to Netapp, they never used to say that we don't know something, because they're paying good money. But this project they are not, even Netapp support we do not have, like, okay, we do not have means we have support, like it's a third party. I don't know what is this name is, some other third party is supporting, and we try to solve the problem on our own rather than going there third party. So anyway, you see this intercluster IPs are leaps are created, right? 120 and 122, okay. Cluster P is also created, bro. What I have to create? This is also created. Cluster P here. Show. So this is also created, okay. If I keep IP instance, cluster P here show status. So cluster 2. Remote cluster, peer cluster name remote 2. What is this? Oh, yeah. So cluster 1 is peer to cluster 2, okay? Cluster 1 is peer to cluster 2. And these are the active IP addresses. So here the leaf is 121, 122. Okay? So 121, 122 is paired with 124 and 123. See, you can have only one intercluster IP also, but normally it's better to have two IPs for redundant purposes. And you can check the remote cluster nodes, okay? So this cluster node is cluster 101, cluster 102. Remote is cluster 201, cluster 202, okay? So you can see all these things. This is already created, so I don't have to create. I've shown the cluster peering. I'll show you the cluster peering in some other session. The reason why I'm not showing this, because this is already created, right? If I created something, so that's the reason. It will take a lot of time. That's the reason I'm not creating it. It's just that you have to do like cluster period create. That's it. And you have to accept the acknowledgement in other PS. Do you remember I created the cluster peer in SVMDR, not SVMDR, global mirror, sorry, metro cluster, okay. And I had to accept from the other cluster the big passphrase, right? So similar thing I will do here. The concept is same. And here there is one more thing which is pretty different. which is there is one concept here, okay. This one, on-tap mediator, okay. Same thing we have in software defense, we call it as on-tap deploy, okay. So on-tap mediator is, what is this? It's like a quorum disk, okay. So this is the disk, okay. So this is like you have used Vplex, right? Vplex witness, right, in EMC. So similar to Vplex witness. So it's something, right? It will record the heartbeat from from the nodes, and it will be aware of the state, like this node is on, okay, this node is on, this node is healthy. So it will know, and it will decide one node is down, then it will decide, okay, this node is not healthy, so let us fail over to other node, okay. So whenever you are getting any network issues or any disk hardware failure issues, so it will check that which cluster is down, and this scenario is called as split brain scenario in this Netapp, Snapmirror active sync, okay, split brain scenario, and it will decide uh, which node we should fail over everything to, like this can all, okay, we should fail over to. So the volumes will fail over to. I mean uh, the I would say the IO will fail over to that, those volumes in that particular cluster, okay. It's basically uh, it's basically installed on RHL, okay. This mediator, it's basically software, and it's basically installed on a RHL system, okay. in uh, in Hitachi also you have a concept of quorum disk, GAD quorum. So you'll do the same thing, you'll be installing it in a separate site for the quorum disk, okay. Same concept. I think everybody is copying everyone, like, let me just drink some water, 1 second. So I have to do LAN application, right? So what I have to do is I have to check the LANs. What are the LANs I have? I have 88%. I have these LANs, okay. This is iSCSI, okay. These are the LANs we have, okay. If I just click on iSCSI, then what can I see? This is the junction path, okay. Mm, yeah, so this is already allocated to this initiative group demo underscore one. So this is already allocated to some server, okay. In this case we are allocating these to two SQL servers and one ESXi host, okay. We'll verify the connectivity that we are able to access the LANs from those hosts or not in later of this session, okay. So this is a thin provision LAN. You know that, thin provision, what is thin provision, what is thick provision, right? You know these things. LAN format is VML. So this is something there, okay. Path, junction path, right? Junction path, but one more thing, why is not able to see the, okay, this is not junction path, this is LAN path, okay, that I need to mention. This is not junction path. So if I give like LAN show FTP server, I need to give, yeah, you see this, right? This is a LAN path actually, this is not a junction path, okay. What is this, yeah. Yes. Yeah, you have to, if it is iSCSI, you need to go to the iSCSI initiator in the Windows operating system. You need to find the big ID, and you have to you have to run the command LAN map command, LAN map show. Sorry, show is not there, but LAN map is the command. Okay, LAN map is the command that you need to use. Okay, I don't know who's pinging me. One second. Oh, Java is pinging. Okay, so that's the thing. Okay, so anyway, this is cluster one, right? Now I have to. Okay, so I logged into cluster 2, and then I'll check the same thing like intercluster. Mm, yes, it's all green, no problem. Cluster PR, yes, cluster is PR. It will show obviously okay. Mediator, VM, everything is okay. Problem. If you see any unhealthy status, right, you have to troubleshoot. But it's okay, not a problem. All are healthy. Okay, and we have the SQL server, right? So we'll check the SQL server. Okay, I'll just go with this RTP. SQL password. We do disk management. Okay, here I have both the labs here, SQL on DB and SQL on logs, which I have not here, sir. This one, you go to lunch, right? You can check SQL DB, SQL on logs, right? These two things is there. These two things I have allocated to this post, and this online, simple online. No problem online. Good. Okay. I'll also check the database files that I have. I need to check the database files. So what I will I'll go to the SQL Server Management Studio. This is software. This is software that you need to install to manage your or to do administer your SQL Server databases. You can create or modify any database objects. You can run different SQL queries. Okay, and you can also manage the security and performance of the database using this software, SQL Server Management Studio. My brother knows SQL well. I don't know that much. I just only know how to create tables and all. Oh, no. So just connect. Then databases, database management, application management, custodian logs, you can see the files here. Mm, if data and these files are there, okay. So the paths, okay. So log file is on G drive and others are on F drive. Okay, you can see those things. So I'll just cancel this thing and minimize this software. Okay, no problem. I'll check whether the database is good or not. The database status, okay. So I'll just open this. Let's try here. Watch. It's something anyway. So just leave that. Okay. So normally you have to check whether the database is good database online or not. Okay. So normally you'll have the things bookmarked here. I don't know why it's not here. But anyway, so we have to check that one. Okay. So probably we'll check with database team. They can help us with this. Okay. Whether the SQL is online or not, they can check and they can let us know. Okay. So somewhat is. Okay. So now what we'll do, we'll just check the VM environment. So we'll just minimize this. We'll need later on this. So just click on this. We'll be logging here. One second. আমি খেতে পাচ্ছি না এখন। পরে খাবে? So here, this VMware, the vCenter that we have, right? We can use this to manage the virtual infrastructure resources that we have for this Intel environment. Okay, here we have what we have here. One second. Inventory, already in inventory. We have 4 ESX server here. Okay, we have 4 ESX server, and we have lot of VMs in multiple sites. These are the VMs we have. Okay, so in VMware vSphere, we need to have one more feature, that we can use with Snapmirror ActiveSync, which is VMware vSphere Metro Storage Cluster, VMSC, VMware vSphere Metro Storage Cluster. Okay, like we have SRM, right? You know the site recovery manager, right? Is SRM in VMware, right? ESX server. I'll also show that one SRM. So we can integrate any replications like Hitachi, not with this is for Netapp only. I'm talking about SRM, Hitachi or Netapp. Okay, so here we can integrate the Netapp replications like Snapmirror ActiveSync replications with this, so that the VMware can manage, VMware can seamlessly do things. Okay, so that is the thing. uh, I can share you some product documentations if you want to read, more about that product. Will not. I'll, yeah, VMSC. So
Please ask your exposure. আমি বলে আপনি সাথে প্লিজ এটা বুঝে না আমার এক্সপেরিয়েন্স ছিল অনেকে কি
না না না, কিছু ইয়ে করতে দাও, কি হচ্ছে? So it's a cluster one. I can see this is what VC1 D1 Netapp one can be called on. So explain this one. Yes. Okay. Go to this cluster. Go to this one. Summary. I see this thing. Okay. It was something. What about single one? Don't see much. Don't see much of a problem. Schools. That you can, that you need to create data stores. I need to go to data store. Here, if you go right, you can check this thing. Okay, so this is basically you can check the data store here, and in the data store you can check the capacity, like it's 100 GB capacity, this much is free, so you can check here. Okay, and I can check for other servers also, other VMs also. Okay, if I go to VM demo, this one, right? It's or maybe secure to, right? Then I go to data store. Yeah, data store already here. ICE 2. You can see at same like 100 GB capacity. Okay. Yeah, so you can see all these things here. now we'll go ahead and create configure the protection. Okay, so we are doing the the Snapmirror active sync between this cluster 1 and cluster 2. Okay, so here I will just log into cluster 1. So the first thing that I have to do is I have to protect the consistent group. Okay, so here the consistent group is, what is this consistent group? Okay, so consistent group is an entity which helps you to maintain the data consistency between across multiple volumes in a storage system. So it will simplify the process of management of multiple lumps. Yeah, so just let me just do this thing. We need to go to the cluster 1 storage. So this is the cluster 1, cluster 2. So this one is production, this one is DR, something like that. Okay, or maybe this can be, both can be online, because this can be also active. So we can create a new one. Okay, SQL on DB we have, SQL on logs we have. Yes, yes we have. I need to select the destination SVM, which is this one. We have the destination SVM here. You can check here, cluster 2 storage SVM. If we do not see here, yeah, it's here running iSCSI. Okay, only iSCSI is here. I'm using only for iSCSI lumps. So I go here. Okay, I'm creating, yeah, I'm creating a source cluster 1, not destination. Normally in Netapp, the management will be done from destination cluster. Destination cluster. Yeah. Save. Return. Okay. So it shows healthy relationship is there. Healthy sync is there. So I'll check the relationship here. Let us wait few minutes. Okay. Job show. Job show. should show here the destination, right? That's the same thing. Should probably show here. Yeah, you can see here, right? It's already it's showing us in sync. Yeah, so it's showing here. There's a problem in Netapp. You never know where it's going coming. So now what I can do is I can check this. Uh, I can check the host, okay? Like the initiator groups, this is for ice cases, I'll be checking the initiator groups. Secure one, secure two, no LANs mapped, okay. So I have not mapped the LAN, fine. Map LANs, okay. I'll add the LANs here. So the LANs should be like secure 1 dB and secure 1 dB and secure 1 blocks. So I have mapped the LANs here. Okay, this is distribution of the LANs here with ID is 0 and 1, okay, no problem. So I created a constituency group, and after I created the constituency group, I can see that it's being like I can see the uh, status as 1 second. I can see that it's healthy, right? Automatically failed over. In sync, I can see it's in sync. Okay. The protection policy is this policy I have not this is synchronous policy. It's automatically it's taking automated failover policy. So means it automatically it will fail over if some problem is there, okay? So it will automatically fail over. That's same thing it happens in metro cluster also. Okay. Now I have to verify that that active sync relationship is working. The data is constantly replicated not, okay? So what I have to do is I can go to this. Sorry, I don't understand what you're saying. Okay, non-business hours. Non-business hours, right? Initially, it will do full copy. Then it will do incremental. So obviously, it will take bandwidth. It will take bandwidth. Better to do in off business hours. Better to do it in off business. Better. You are asking to schedule the copy, right? It depends. Yeah, you can do that in normal Snapmirrors, right? Okay. Here I have to check. Here I have to check. I'll give you the yeah. I have to check. Normally here also you can do like here Snapmirror policies are there, right? You can mention you can run the you can add like a schedule here cron job, and you can mention at what time the you can mention what time. 1 second, let me switch this. You can mention at what time this replication will be done. You can mention that in the job cron job schedule job. You can do that. Okay. So yeah. This This is my disk management, yes. I did rescan, the reason why I did rescan, because here in SAN, right, you have to manually ensure that that it's updated. So you have to rescan the disk. Okay. Whenever you are doing this replications or something, right, you have to rescan, so that the system recognize any new changes. So that's what you have to do. That's the problem here. You don't have to do an you have to do here. You don't have to do in NAS, but you have to do in SAN. That's why nobody likes SAN in Netapp. You don't need to do in Hitachi. Do you understand, right? You don't have to do in Hitachi is HP only. Are you using block storage in HP, right? Yeah, changes means what? You don't see. Changes means if you are expanding, if you are extending any LAN or adding new paths, then you can ask for a scan. But for application, you don't ask, right? Normal application, you don't ask for a scan, right? But here you need to rescan. So you can see the multiple paths here. All are uh, two are active optimized, another active unoptimized. Okay. Why? Because cluster 1 is active optimized and cluster 2 is active unoptimized. Okay. And this uses, is ALOA. Like, you know what is ALOA, right? ALOA is a concept like it called as like asymmetric logical unit access. Okay. So it will identify the optimized paths between a storage system and the host. Okay. And the LAN will use that path. I mean, the host will use that path to read or write data to the storage subsystem. Okay. So this allow will enable the initiator, right? The high-scale initiator, okay, or normal node initiator, okay, to query the target path, you know, query the the node, the server, okay, about the path that we have, which one is active optimized and which one is active unoptimized. It will query, and it will allow the target to communicate back to the initiator. Here the cluster 1 is active optimized and cluster 2 is active unoptimized. Okay, I'll just exit this. Okay, I'll just do an exit. So now what you can see is that the Snapmirror active is now it's in sync. Okay, and the SQL workload is also protected. We scanned this and it's also protected. There was one option to see. I'm not able to see that, like the database is in sync. Okay, there's one option that I need to check that database is online, but I'm not able to see that here. Okay, for some reason it's not here. Internet Explorer. Internet Explorer. I don't think it is an Internet Explorer, but let's try. No, there was a code that was bookmarked to it. Okay, because normally will storage administrator will not know much about the database, so it's something I don't know how to check that. How to check whether SQL database is online or not. Okay, you probably have to coordinate with your SQL admin, and they can let you know. This is I did for SQL Server. Now I'm going to do for VMware ESX. Okay, ESX servers. Okay. So, select this. I just minimize this. Now I'm going to enable the vSphere high availability. Okay, and configure the vSphere high availability. So we can do from here. Here. vSphere H is turn away to enable it. So it it is showing us very easy right here. It is showing, but it's not that easy. It's like the problem is, to know this we have to know a lot of other stuff. It's already pre-configured, that's why it's showing like this. But so here, whenever this is host failure, then it will restart the VM. Okay, VM monitoring is disabled because it will take some resources. It will take some CPU utilization. So I'll just keep okay. I'll just go with the default options. Uh, Now it's showing us turn on, right? It's turn on. Okay. I want to do it up. I'm trying to get this up. Okay. One second. Yeah. So these are the recent tasks which was done when you turn the high availability for the vSphere on. Okay. You can check the task, it is being executed. Compliance of cluster with image set solutions. It's enabling the vSphere HA. Okay. It has already done the Netapp storage discovery. It has already discovered these things. Okay. It is already done. Now it is just reconfigure the this one also doing just is doing the HA configurations. This will take few minutes. Yeah, SRM is different. Yes, yes. I'll show you SRM. I'll show you SRM. Okay. This is different. I'll show you how to configure that in one of the labs. SRM is used in long back though. I mean, it's still in use. 2011. Now also it's in use. Cloud is much easier, bro. If you want to learn story, right, it's much more difficult than cloud. Cloud is much easier. In Netapp, in previous session, I showed what metro cluster, Snapmirror at volume level, asynchronous, then SVMDR. These three things I showed here. It's thick enough. Normally you'll be using those kind of applications only. Normally, if you have something else you can use. Yeah. So basically these are VM host rules. Okay. So what is VM host rules? This is basically um, it's basically creating a relationship between a VM and a host group. Okay. So show you this things right. Just options are there. Keep virtual machines together. Separate virtual machines to host. Okay, so it will map the virtual machines to host. Okay, and virtual machines to virtual machines. Okay, okay. These things will not be created by us, bro. These things will be created by the VMware team, bro, not by storage admins. We will not create this. This VMC, this will be configured with the VMware team, okay? And then once they configure, then we can do failover operations. We can do like a DR testing. It's like quarterly or something. We can do a DR testing for a planned failover, and then we can also enable for automatic failover. Suppose some complete site failover is there, then also we can manage. And then once it is restored to normal operations, then you can also fall back to it. Okay. So first I will just do a planned failover. We need to do planned failover because we need to understand that in case of disaster we can really do this. So we have to do testing for other applications. So that's why we do disaster recovery testing, DR testing. But fortunately, it does not happen in my project. That's a good thing. But most of the projects that I work on, right, every I don't know, quarterly or monthly, there's been some activity, data testing activity, mostly for EMC. So here, this is like suppose we are just assuming that the node, the cluster one is it's not working, right? So we'll just switch over to the secondary side, and we'll check the data consistency, whether it's the application team will check the data consistency, okay, to show that in case of disaster the business will be in compliance. So we need to check that as. So we need to manage from the destination cluster. Destination cluster CG SQL and CG, destination cluster SQL and CG, CG. Ice cursor SQL on, yeah. This is SQL Server. This is VMware. So I'm just doing for the VMware. Okay. Failover. So source is this one. Destination is this one. Is here. This is failing out of this one. Okay. Okay. If you are trying to do volume move or some other task, right, you cannot do this. So you should not execute any other task when you are doing this. Okay. Should not. Yeah. So it is. Okay, it's gone, right? So I can see from here. You see, right? It's here, right? It's failed over. And then you can see here, right? This thing was here, destination cluster. Now it's in this cluster. Okay. So this is the destination, and this is the source. Cluster 2 became source. Okay, and cluster 1 is the destination. Okay. And this is source. This is managing this SQL one. This one. Okay. This is source. Okay. SVM1. So I'll tell you one thing. For this LAN, LAN or the volume, okay. So which is the source? The source is SVM1 cluster 2. That means the second one. This is Mumbai, Chennai. Chennai is the source, and Mumbai is the destination. Here, Chennai, Mumbai. This is Mumbai. Mumbai is the source, and Chennai is the destination. Okay, you can understand, right? So that's what it happened. I am not able to show you the database online status in SQL. Use. Okay. The bookmark tab is not here. So now, as we have done we need to check. We need to contact the security, SQL, and ask the SQL administrator to check whether the SQL is online or not. SQL database online or not. If it is online, then it's good. Then its disaster recovery testing is completed. Then what we have to do is we have to again make it normal. Resync, like keep the cluster one, like fall back to it. Whatever we did, right, we need to fall back to it. So we have to check. Not here, sorry. We have to come here. This is cluster one, right? Again. So source should be this one. That's probably, yeah, it's okay. It's not here, right? In cluster 2, I can see this. In cluster 2, I can see this, so I can go here. Password is so you can see, right, now it is failed over, right? So now it is okay. In sync, it is showing as in sync. Snapmirror. If it is transferring, right, it will show us transferring. Okay, I mean it is updating. Snapmirror update. It's maybe very less data. That's why it's getting synced very quickly. Yeah, we have to contact the plant flavor also. Okay, every now and then to because of compliance requirements, security requirements. In some projects, we have to do this. Okay, this is plant failover. Okay, now I will try to do like automatic failover. Okay, I will just try to check automatic failover. What happens in automatic failover? Okay, so let me drink some water. Here I will just simulate a situation where cluster failover has happened, and we'll try to see that automatically, the automated planover feature, that failover feature is there, which takes in effect or not. We need to check that. So what we'll do is we'll go with this here. Enter new tab. Oh, sorry. The database status was here. Chha, this is online. I was looking for that in that RDP session. Okay, pause for 2 seconds. So I'll shut down cluster one. Okay, cluster 101. I'll shut down both the nodes in cluster 101 and cluster 102. Okay, and then I'll check what will happen. Shut it down. No, this is not VMware. This is which one? Which one is saying? This one. This one. This one. This one. Power control, right? It's see, this page is created by Netapp developers just to show you that what happens in real time scenario. This is, you will not get this page. You will not get this page in real time scenario. This page you will not get power control page where you will have like power control of every other host another thing. You will not see this page. You have to this because shutdown. You have to go to the data center and you have to call. If you Yeah, that's what I'm able to do. But otherwise, I have to go to a data center. It is not possible. You can shut down software defined storage, yes, but not physical storage remotely. It depends actually. For Netapp, not I'm talking not Netapp, Hitachi for some entry level storage array, you can shut down remotely also. There was one storage I forgot the name. Is it Cohesity? I think Cohesity. You can do remotely shut down. Cohesity, I think. There was one lady. She will take my training. I think for next week. She is worked on Cohesity. So nowadays backup jobs are less and storage job is more. I don't know what is going on. So anyway, so I'll just power this down. Power off. I know it will happen because, but you should also know cloud and cloud automation. You should not always rely on one technology. So anyway, but if you're working TCS, right? TCS is always safe. Even if you don't know anything, still your job is safe. TCS is like that, yeah. Because I saw a lot many people in TCS were not doing anything, just sitting idle. Anyway, due to so I have powered this off, right? This is I'm able to do this because there's a lab. Otherwise, I cannot do this. You have to go physically and do it. Okay. So this is just you can see sim box. This is sim box it having sim box. Okay. And the version is Oppenheimer or something Klamheimer, something like that. I don't know why it's not working. I'm not able to. Got disconnected. Or what? Oh, the reason why it's not. The reason why it's not happening because I have shut down this, right? See. So that's why it's yeah. That's the reason why it's not happening. So here, claw hammer. Okay. We do not have any voice called claw hammer in that tab. Okay. Like I have never used it. Claw hammer. Latest one I'm using is 9.13.1P5. So I'll shut down this. I'll go to the cluster 2. Let me go to the power control. Cluster 2. Okay. Should come something. Should come because my cluster 1 is down. Why it's not there? Should come. Yeah, it will not come because it's shut down, right? It will show like this only. But here, what is this? Let us wait for some time. Let us wait for a few minutes, okay? Let us see. But I just want to see it. There is some issues. There is some issue here. There is some issue here. Let me just re-log in. I'm not shut down the part. This one, right? If I've not done it. I've done it. The rules I created at VM rules and everything that on ESX server, we're not going to create these rules. VMware team will do this, okay? We're not going to create those rules. And also, SQL will not manage the SQL server. Will not do everything. Will not be a storage guy and a database guy and a backup guy and a VMware guy. We can be, but it's not like a person who works as astrologer. They don't do operation job everywhere because then we will not have time to do anything. That's yeah. Adding in. That is still what they say that is will be checked. Emergency event. Yeah, peer cluster one is no longer available. Because why not available? Because it's shut down. You have shut it down. That's why it's not available. I have no idea why it's not coming. Why it's not coming? Why it's taking this much time? It should happen immediately. What is happening? Second. We call it one way. It's not a way. Just wait for some moment. You have to try again. You have to try again. So it's running. It's again I need to power on. When I teach you guys combo, right, it will take like 2.5 hours. That session can be like 2 sessions, I think. That one is very big. I also teach you guys DevOps. Like DevOps means like creating the YML files for Docker and Kubernetes, and then how to troubleshoot when there is some storage issues. How to find the persistent volumes, the IPs that the dynamic IPs that the pod is using. So again, I will try. Okay, again I will try. I'll try again. Creating a course in Udemy for Hitachi student, but firstly like basic things I'll give you. So Hitachi, just give me a course. You can go through the videos here, okay? You can go to the playlist here. Okay. So, go home. Go to YouTube. You can go through that playlist. You can go through all the videos here. Okay. And you can go to the Netapp basics. Combo lab was not completed. I have to redo this again. It was a big lab, so again I have to redo this. So, the process needed. Oh, because I removed the audio, but I'll have the sessions right. I'll view the audio for share purpose, and the audio one I will share remote like privately. So today you have today is an Netapp session, right? Tomorrow I'll be traveling, so tomorrow no sessions probably. Mm, after tomorrow, yeah, there will be sessions. So get that. Just have to wait. Tomorrow retouch. See what is happening. We done. No, it's not done yet. It's not done yet. Anytime you do anything else, keep on seeing. What's happening? Nothing is here. It has come back here. It will take a lot of time, guys. Do anything. Just this one here. So how long it will take? How long it will take? Just do something here. Leave it. Astra Control Center, and also it is having Trident application. Astra Trident, okay. Like Astra Trident is for storage provisioning and orchestration, okay. And Astra Trident, Astra Control Center, Netapp is having its to protect the Kubernetes applications. So Netapp is selling a lot of things. So those things also, I think, maybe not required. Astra is required, actually, means Astra Trident is required because in my project, like, they are using Astra, so they get some issues every now and then when you do when I do migrations, something like that, or upgrade, then I have to fix the issue first from storage end. So that is there. This is very bad. What is happening? It is still running. Let's do this again. What I'm trying to show is that one is shut down, right? Still, the database will be online, okay, and the volumes will be in cluster 2. It will be in cluster 2. Here it will show this. What happened? Is happening? This got stuck. Guys, can you hear me? You can hear me, right? The problem is, uh, this is not getting. Okay, let me share the screen again. The problem is it's not getting shut down. The simulator is not working properly, so it's not getting shut down. If you see, right, this one is again. I'm trying to shut down. Okay, so that's the problem. It's not getting shut down properly. So I think this network is working now. It's not working yet. So main concept is to see that once it is shut down, I should see this here. The Snapmirror should see here, and I should see the DB status is online. That is the main thing. DB status is online even now, but I should see this thing here failed over. Status failed over. So that's thing I'm not able to see. The reason being this is taking a lot of time to shut down. It's not in my hand. It will take some time to shut down. Yeah. I think it's shut down, right? No, no. I don't know. Why it's not getting shut down? See, I'm trying, but it's again probably I don't know. Maybe they have some issues with the simulator lab. So it's another thing. Okay, leave it. If it's not shut down, I'll just power it on, power it back on. I'll just continue with you know. I'll just show you one more thing. One more thing I'll show you. I'll show you when what happens when the complete site failure happens, right? And then what should you do? What is what can you see here when complete site failure happens, right? Then how can you see the database and ESX servers? Okay, like what is, and then you can roll it back when it is everything is fine. You can restore to normal operations. But I think it's same. Let me just see one more thing. If I go to vSphere VMware, right, this what is happening. 1 second. If I go here also, mm, these are my host, right? These are my host. You see everything is okay, not this. I want to check. I want to check the data stores. Data stores. Yeah. thing I want to check was check the lumps I had. Storage lumps. Yeah. Security iSCSI. What about this iSCSI 1? iSCSI 1 out of sync. Okay, is out of sync. What about SQL DB1, which I did? SQL 2 logs, which I did. Unprotected. I mean cluster 2. iSCSI 1 cluster 1, iSCSI 1 SQL 1, iSCSI 1 SQL 1, iSCSI 1 SQL 1. SQL 1 is still not, it has not come back to here yet because it is not completely shut down. Wait again. So you can see here, right? iSCSI 1 is here. You can see iSCSI 1 is here, but it's out of sync. It is not in sync. Okay. I have to, it has to properly shut down. What is this? Okay, it's, I think this is not, the simulator is, I'm having some issues. The simulator is having some issues. Leave this. Okay. So the main purpose was for us to see was that we had two LANs, right? One was iSCSI, one is SQL 1. This iSCSI 1 was for ESX server, VMware, and this SQL 1 was for SQL. Okay, and I can see both online. I wanted to see that this both is showing here in cluster 2, but for some reason it is taking a lot of time to shut down, and I'm not able to show you guys. So here you can see iSCSI 1, right? iSCSI 1, you can see it's online. There is no issues here. Okay, and you can also see you can see DB status is also good, so it's working, but out of sync. Out of sync means we do not know the data consistency. We are not sure about the data consistency yet. The reason is, it should show in sync, in sync. So it's taking, it's a simulator, it's not real time situation, so it will always have some issues. So it's taking a lot of time. So I'll just